Am I audible, everyone? Okay. So, in yesterday's class, we have learnt about array, right? Single and multi-dimensional array we have studied. Okay. In today's class, we will have a solution for the uh, abstraction. Okay, we will have a solution for the abstraction. Okay. Now, guys, can you tell me, like, can we achieve 100% abstraction in an abstraction? In abstraction, can we achieve 100%? Is it even possible? Yes, quickly. Yeah. No. Why we can't achieve 100% abstraction is because of a concrete methods. Because of concrete methods. Okay. So because of those methods, we are not able to achieve 100% abstraction. Okay. Concrete methods means the methods which give implementation to the abstract method. Okay. Concrete method means the method which gives implementation to the abstract method. The method which give implementation to abstract method is called as concrete method. Okay, is called as concrete method. So which means, in short, in short, any method which has a block. Implementation means what? A block. A method is having a block. It's called as a concrete method. It's called as concrete method. Okay. Now, concrete methods are a non-static methods. Concrete are non-static methods, and non-static methods with the block are not allowed in abstract class. Are not allowed in abstract class. Not allowed in abstract class, right? But but here in the abstract class we are able to write it. It is allowed. It is allowed. In abstract class we are able to write the concrete methods. We should not allow it actually. In an abstract class, we should not allow concrete method to achieve 100% abstraction. But but here here since you can write concrete methods in the abstract class, we will not be able to achieve 100% abstraction. We cannot achieve 100% abstraction. The solution is we shall go for the interface. The solution is the solution is interface. Okay, solution is interface. Okay, interface is a component in our Java. Interface is component in our Java which is used to achieve 100% abstraction. Which is used to achieve 100% abstraction with with multiple implementation. With multiple implementation. Okay, with multiple implementation we'll be able to achieve 100% abstraction. The solution for abstraction is your interface. Okay, using interface, okay, we'll be able to achieve 100% abstraction with the multiple implementation. With the multiple implementation, okay, there is a solution for abstraction, that's an interface. Now how to create an interface? Okay, how to create an interface? So let us see the syntax of the interface. Let us see syntax to create an interface. Syntax to create an interface. Okay, so now we shall know the syntax to to create an interface. Okay, now what is the first thing is you need to have an access modifier, which is not mandatory. Access modifier, you can have an interface keyword, and you can have interface name. You can have interface name. Okay, you should have a access modifier prefixed, but it's not mandatory. You can have an interface keyword and an interface name. Just like class and class name, you should have interface and interface name. Okay, and an interface will have a block. interface block. Interface will have a block, it is called as interface block. And and we will declare the members here. We will declare the members of the class here. Okay. Now now see, this is not very different from the class. Okay, it's not very different from the class. Even interface files, if you take, okay, if you take a interface files, okay, so if you take a dot java file, after compiling it will become dot class file. It will become dot class file. In the same way, interface also should be saved in the form of dot java only. Interface also should be saved in dot java, and after compiling it will become, dot class. It will become a dot class file. Okay. And and here let us write one interface example. Let us write one interface here. So we shall go for interface demo. Okay, and this is your interface. Demo is an interface. So compilation before compilation it is in the form of demo.java, but after compilation it will be converted into abstract interface demo. Abstract interface demo. Abstract interface demo. Okay. And here the file will be in the form of demo.class. Demo.class. Okay. Before compiling it will be in the .java format, and here it will be in this format, interface demo. But after compiling it will be in abstract interface demo format. It will, after compiling it will be in the abstract interface demo format. Okay. Now, so this is about a interface. And one main thing we have to know, that there are so many members which are not allowed in an interface. There are so many members which are not allowed in an interface. Now let us see what are the class members which are not allowed in an interface, which are not allowed in an interface. Okay. Now let us see one by one. So let us take a new file. Okay. So let us see the first one. Let us make a tabular column actually. So we shall take the class members here. We shall take a class members, and we shall see if it is allowed inside class and if it is allowed inside interface or not. We shall see if it is allowed inside a class or it is allowed inside a interface. So first member we take, that is your static variable. Static variable. Okay. Static variable you can write in a class. Yes, you can write in a class. But in an interface, can you write? Yes, it is possible. In an interface also, you can write a static variable. In an interface also, you can write a static variable, but but the interface should be, I mean, that static variable which are you're taking in an interface, it should be only only final static variable. Final static variable. Okay. See, when a variable in when a static variable is prefixed with a final, means you can't change the value of that variable. When a variable in a static variable is prefixed with a final keyword, then then you can't reinitialize. You can't reinitialize. Once the value is assigned, that's it. You can't change that value again. Okay. Here, in an interface, you can write the static variable, but only final static variable you can write. The static variable can be prefixed with the final keyword. Okay. After prefixing with the final keyword, you can't change the value of the static variable. Okay. So static variable is allowed inside interface, but only final static variable is allowed. Excuse me. So now let us come to your non-static variable. Non-static variable. Okay. So non-static variable, obviously it is allowed in a class. We can write everything in a class. Okay. But in an interface, In an interface, you cannot write a non-static variable because like we can't create an object in abstract class, here also we can't create an object. For interface also we can't create object. Okay, since we can't create an object for abstract class, okay, we can't even create an object for interface. We can't even create object for your interface. Okay, so here there is no non-static variable allowed in an interface. Okay, so there is no non-static variable allowed in an interface. Okay, next we'll go for static methods. Static methods. Okay, static methods are allowed inside class. Yes, but is it allowed in an interface? Yes, static methods are allowed in an interface, but from which JDK of which version? From JDK of from JDK from JDK 1.8 version. From JDK 1.8 version, static methods are allowed in an interface. Wait, but from JDK 1.8 version, your static methods are allowed in an interface. Okay, but one twist is here, whatever the static methods are there, all the static methods by default should be public in nature. They should be public in nature. What all the static methods we have to write inside an interface, they all should be prefixed with public keyword. All the methods, all the static methods should be prefixed with public in a interface. Okay, now let us get into next one, that is our non-static methods. Non-static methods. Okay, so non-static methods are obviously allowed inside the class, but in an interface it is allowed. Yes, it is allowed, but but we can have only abstract non-static method. Abstract non-static method only we can have. Okay, only only we can have a abstract non-static methods. We can have non-static methods in an interface, but they should be abstract non-static methods, which means both the non-static methods should be prefixed with public and abstract. They should be prefixed with public and abstract. Okay, so you can have non-static methods inside the class, but inside the interface you can have a non-static methods, but it should be in the form of abstract non-static method. Abstract non-static method. And all those non-static methods by default they should be public and abstract, not only abstract. In interface all members you are taking, they should be public abstract in nature. They should be public and abstract in nature. Okay, next let us go for constructors. Constructors, see, constructors are allowed in a class, but in the interface constructors are not allowed because we can't create object for interface. That is why you can't have constructors. If we are able to create object for constructors, if you're able to create object for interface, we could have created a constructor, but since we can't create object in an interface, we can't have constructors. Okay, next, so last one is your initializers. Initializers, so initializers you can have non-static and static initializers. Non-static and static initializers, both non-static and static initializers are allowed inside the class. Yes, they are allowed inside the class, but in interface in interface they are not allowed. In interface they are not allowed because to initialize them we have to create object. To initialize them we have to obviously create a object. So we don't have to create object in an interface because we can't create it. So since we can't create, you can't have a initializers, whether it's a static or non-static, both we can't have. Okay, and one more main thing, in an interface In interface, by default, all the members of interface should be public. All the members of interface should be public. All the members of interface should be public in nature. All the members of interface should be public in public in nature. Okay. Now now here we can achieve 100% abstraction in an interface by not allowing concrete methods. By not allowing concrete methods. Okay, we can achieve 100% abstraction in interface. We can achieve 100% abstraction in an interface by not allowing concrete methods in an interface. By not allowing concrete methods in an interface. Okay, now let us create one interface in your Eclipse. Let us to create. Okay, we shall go for a project E23. Okay, abstraction. Okay, now let us create one package where we write interface programs. Interface. Okay, interface programs. Okay, under that package we shall create one class. We shall create one class. The class name we shall take demo. Okay, now we have a class demo. Now, as I told you, see here we have a class. Easily you can change to interface. That's it. You can remove class, you can place interface. This is one way of creating interface. Okay, this is one way of creating an interface. Okay, next second way is if you click on the drop down button beside C plus, okay, beside C plus, okay, I mean where you create a class C plus, there is a drop down button. If you click on the drop down button, you can create a JUnit test case, a class you can create, interface you can create, enum you can create, record you can create an annotation. But we want an interface. Click on the interface. Obviously nothing else it will show. You can give a interface name demo1. You can give like this. This is second way of creating an interface. Okay, suppose by mistake you created a class, it's okay, you can remove and you can write interface. Now currently we are in an interface. As I told you, we are not allowed to write a non-static variable. If we write a non-static variable, we'll end up with a compile time error. Okay, we'll end up with compile time error. The blank final field a may not have been initialized. Okay, here it is telling to initialize. Okay, now now you should know that see, if you initialize now 10, it is accepting. Why? Because I told you non-static variables are not allowed. Yes, it is not allowed. But what is this? Is it non-static variable? It is visible as a non-static variable, but it is prefixed as, by default it is prefixed as public static final variable. If you don't mention for a static variable, if you don't mention public static final in an interface, by default your compiler only gives. By default, your compiler only gives public static and final to this variable. Now this is a final variable. Later you can't change this anywhere. Okay, see, suppose if you have main method. Okay, you have main method. Now inside the main method, you are trying to you are you are you are trying to print a variable a. Okay, you can print a variable. So let us execute. Okay, so can you see 10 here? Yes, we can print something because I told you we can have static methods in an interface. We can have we can have static methods in an interface. Okay, main method also can have. See, I am printing a, but now I wanna try to change the value of it. A is equal to 15. A is equal to 15. What am I seeing? The final field demo dot a cannot be assigned. That means reinitialized. The final field demo dot a, because this is a static variable. No, you can call it with class name. I mean interface name dot variable name. Okay. Now here here you can't reinitialize a final static variable. Final variable you can't reinitialize. If you try to do, you'll get a compile time error. As of now, we are getting it. The final field demo.a cannot be assigned. Okay, so you can print it. You can use it wherever you want, but you can't reinitialize. You can't reinitialize. Okay, this is about a variable. Final static variable. Okay, public static final int a is equal to 10. Later you can't change the value. Okay, so this is about your final static variable. Now if you try to write a concrete method, that is public void, suppose in test method, if you take, this is a normal test method and this is a concrete method because it has blocks. Okay, so since it has blocks here, we can't write it here. We can have only abstract non-static methods. We can have only abstract non-static methods. Normal non-static methods are not allowed. Like this, we can achieve 100% abstraction. Okay, and if you have to write a non-static methods, we can write it as public abstract void test method semicolon. You can write abstract methods in an interface. Okay, you can write abstract methods in an interface, but you can't write non-static method. Okay, so next why do we need an interface? I already told you, right? We need interface to achieve 100% abstraction and to avoid concrete non-static methods. Just now we have seen a concrete non-static methods. Okay, to avoid to achieve 100% abstraction and to avoid the concrete methods. Okay, we are going for your interface. Okay, and you guys remember, in multiple inheritance we got one problem. Yes, everybody remember, in multiple inheritance, in inheritance concept, we have come across one problem. What is the problem name in multiple inheritance? Yes, good. That problem name is diamond problem. That diamond problem also we can solve using your interface. Using your interface, okay? In your interface, you will get a solution for the diamond problem. You will get a solution for that diamond problem. Okay? And and now what we shall do is, let us understand inheritance with the help of interface. Okay? Let us understand inheritance with the help of interface. Okay, now now let us start inheriting. Okay, let us create one class. Class interface i1. Okay, interface i1 only we have to create interface i1. Now interface i1, suppose they have one abstract non-static methods. Listen carefully. Public abstract void test method. Now you can have a abstract non-static method freely in your interface, and you can also have a static method. Now let us have one static method. Public static void exam method. Okay, so in the exam method we shall type examination. Okay, examination. So in an interface, currently you have these methods. This is one interface. Now let us create one more interface. Public interface. Okay, public you can't use. Okay, we'll go for interface I2. So interface I2 inherits I1. Okay, interface I2 inherits I1. Okay, now interface I2, let us extend. See, interface to interface inheritance. Okay, interface to interface inheritance, you can use extends. Okay, so I2 interface I2 extends interface I1. Interface I2 extends interface I1. Okay, now in here if you see what all the members are there in an interface, the members which is present in this I2 interface is only test method. Okay, only test method. You can't have a static method gets inherited. Okay, static methods cannot be inherited. Static methods are not inherited. Okay, static methods are not inherited. You can have static methods in an interface, you can have abstract non-static methods in an interface, but only abstract non-static methods can be inherited, and your static methods from one interface to another interface cannot be inherited. From one interface to another interface, it cannot be inherited. Okay, now now see guys, we have interface I1 with interface I2, right? We have interface I1, we have interface I2. Now what we shall do is, okay, what we shall do is, we shall understand the inheritance of an interface. Okay, now one interface, see, you have one interface here. Interface to interface extends, you have to remember, interface to interface it is extends, class to class also it is extends, interface to interface it is an extends, class to class is also extends. Okay, and now here let us understand inheritance with the help of an interface. Okay, so we'll have a multiple inheritance now. Okay, so what we shall have here is, listen carefully everyone. So here we'll have one interface I1, one interface I2, and one class. Okay, okay, first we will have interface only. Okay, we'll have interface I3. Let us see through the interface how we can achieve multiple inheritance. Okay, see, we'll have interface I1, interface I2, and interface I3. I1, I2, I3. Interface I1, interface I2, interface I3. Now this interface I3 inherits I1 and I2. In interface I3 inherits I1 and I2. So interface to interface it is extends. Interface to interface it is extends. Okay, so interface I3 extends I1 comma I2. Interface I3 extends I1 comma I2. Using class you can't do it. If you take class C1, class C2, class C3, class C3 extends either I1 or C1 or C2. Any one. Okay, any one. But interface I3 extends I1 and I2, because in an interface with respect to interface, we don't have diamond problem. We don't have diamond problem. With the help of an interface, we can achieve multiple inheritance. So one interface is inheriting two interfaces at a time. One interface is achieving two inheritance at a time. Okay, so interface I3 extends the I1 comma I2. Any number of interfaces it can inherit. One interface can inherit any number of interfaces, and like this we are solving the diamond problem. Like this we are solving the diamond problem. With respect to interface, there is no diamond problem. So reasons are, okay, there are some reasons you have to know. Okay, reasons, what are the reasons we are able to achieve 100%, I mean multiple interface, we are able to achieve multiple inheritance. Why it is possible? Because we can easily achieve diamond problem, I mean we can easily overcome diamond problem because we don't have constructors. No constructors we have. Okay, first of all, no constructors we have. Second thing, what all the non-static methods are there, they are all abstract. What all non-static methods are there? No, they are all abstract methods, and we don't have to give implementation for that. We don't have to give implementation for that. And one more reason is static methods are not inherited. Static methods are not inherited. Not inherited. Okay, see, if constructors were there, if constructors were there, either you have to give implementation for this, I mean you have to, so with using supercall statement, you have to give, you have to call this or this, anyone you had to call. But currently there is no constructors in an interface, so that is one reason why we can't achieve, I mean why we can achieve multiple inheritance here. Okay, second reason, non-static methods, which is abstract non-static methods. See, if you're inheriting, obviously you have to give implementation. Since in an interface you can have only abstract non-static method, since in an interface you can have only abstract non-static method, there is no need of implementation from interface to interface. You will here just interface, I mean abstract methods will be inherited. They will not be implemented. They can just be inherited. They can't be implemented because in an interface you cannot create object. That is why. Okay. And you can't even create a implementation. You can't give implementation for abstract method in, guys, 1 second. Excuse me, guys. Okay. So here an abstract method from one interface will be directly inherited to another interface when inheritance is going on. An abstract method from I2 also will get inherited to I3, and no implementation will be there. There will be no implementation. Okay, since you can inherit multiple interfaces at a time, since an interface, a child interface can inherit multiple interfaces at a time, we have no diamond problem. And one more thing is, we can't inherit static methods from this interface I1. If you have any static methods, it will not be inherited to I3. If in this I2, if you have any static methods, okay, we can't, I mean it will not be inherited to I3. Okay, like this we can achieve multiple inheritance with the help of interface. The help of interface. Okay, now see, though they can inherit, who will give the implementation? Always remember, always remember, for an interface, for an interface or for an abstract class, for an interface or for an abstract class, the only person who can give implementation is your normal class. Normal class. For an interface, for an interface or for an abstract class, for an interface or for an abstract class, okay, only a class, a child class can give implementation. Only a child class can give the implementation. Okay, now, now one class, okay, one class, if you're taking a class, child class, okay, one class can inherit an interface. Okay, and and a class can inherit more than one interface at a time. A class can inherit more than one interface at a time. Suppose you have interface I1, interface I2, and a class C1. Okay, class C1. Always remember, interface to interface, that is extends. Class to class is extends. But interface to class is implements. If class is inheriting an interface, if class is inheriting an interface, then you have to use implements keyword. See, we have read in the previous concept that you can achieve inheritance with the help of a extends keywords as well as implements keyword. Implements keyword. Okay, now Using extends, we know, we have understood interface to interface and class to class extends only. But but you can inherit an interface into the class and you have to write implements. So class c1 implements implements I1 comma I2, which means here one class can inherit any number of interfaces. One class one class can inherit one class can inherit any number of interfaces at a time. One class can inherit any number of interfaces. And for the abstract methods which are present in these interfaces, in your class you can have implementation. In your class you can have implementation for the abstract methods of I1 and I2. For the abstract methods of I1 and I2. Okay. Now one good thing is, from a class you can also inherit one class. Okay, here from a child class, now you can also inherit one class. So you can take class C2, class C2. See, this is a situation. This is a situation. A class can inherit more than one interfaces at a time. A class can inherit more than one interfaces at a time. But a class can inherit only one class at a time. One class at a time. So now at a time, your class can inherit one class and infinite number of interfaces. Class can inherit one class only and in infinite number of interfaces. So how do you mention that inside a class? Suppose one class C1 is inheriting C2, inheriting interface I1, inheriting interface I1 and inheriting interface I2. Okay, in this time your class will be written as class C1. First you have to extend the C2. First you have to give importance for the class to class only. First we have to give importance. Okay, class c1 class c1 extends c2. Class c1 extends c2, implements, then you have to go for implements I1 comma I2. Implements I1 comma I2. Okay, now when a class is inheriting multiple interfaces at a time, one class C1, it can easily inherit any number of interfaces. So we can write it as class C1 implements I1 comma I2. But but if a class is inheriting any class at a time, okay, it can inherit only one class. We know class to class at a time, one class can inherit only one class at a time. So if your class is inheriting a class and multiple interfaces at a time, class C1, now this is a class C1. Class C1 extends C2. Class C1 extends C2 class, okay, and inherits members and implements I1 comma I2. Implements implements I1 comma I2. So all the non-static abstract methods will be inherited from I1 and I2. Okay. So in a class, if a class inherit an interface, then it has to give implementation for those abstract methods. Okay, it has to give implementation for those abstract methods. Now the twist is, if this class is not ready to give implementation, if this class is not ready to give implementation for these two inherited interfaces, this class can become abstract class. Okay, this class can become abstract class. Okay, if a class, if at all, if this class even is not ready to give the implementation to the abstract methods of interface I1 and interface I2, okay, next it should become abstract if it is not giving implementation for the abstract methods of interface I1 and interface I2. So it is mandatory to make a class, okay, make a class abstract in case it is not implementing. Okay, so who is responsible for that class then? Okay, who is responsible then? So who is responsible is, okay, let us understand it. Okay, see, one class C1 inherits interface I1, inherits class C2 and inherits a interface I2. Now class C1 extends C2, implements implements I1 comma I2. If see interfaces have as abstract methods, abstract non-static, they will be inherited to C1. If this child class C1 is not ready to give implementation, the next child, okay, the next child class is ready to give the should be ready to give the implementation. Okay, so if the child class is not this child C1 is not ready to give implementation for the abstract method which is present in I1 and I2, you have to make that class as an abstract class. You have to make that class as an abstract class. And the next level of child class, so class C3. Now this C3 class can inherit everything from here and it can give implementation. So for class C3 only, we can create an object and access the members. Okay. So this is how you can understand a inheritance with the help of interface. Inheritance with the help of interface. So we got a solution for our diamond problem. We got a solution for our diamond problem. So diamond problem is solved because a class can inherit multiple number of interfaces and one class at a time. Okay, so like this we have solved the diamond problem. And and now here you should know one thing. Okay, you should know one thing. That one thing is listen carefully. If there is a interface I1 and interface I2, we use extends keyword. Okay, and if there is class C1 and class C2, we use extends keyword. Okay, and if 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 a interface is being inherited by the class, okay, if interface is inherited by a class, then we shall go for implements. But a class can't be inherited by interface. Okay, interface cannot inherit a class. Interface cannot inherit a class because class contains class contains class contains concrete non-static methods. Concrete non-static methods. Okay, so clearly your class can't be a parent for interface, but class can be a child for interface. Okay, but class can't be a parent for interface because a class contains a concrete non-static methods. A class contains a concrete non-static methods. So because of this reason, you can't have a class as a parent to interface. You can't have class as a parent to the interface. Okay. So let us see it practically now. Okay, let us go to Eclipse. Okay, interface I1, I2. Okay, now let us go for interface I1, I2. Okay, let us go for a class. Public class E1. Okay. Okay, it must be defined in its own file. Okay, no problem. Okay, we shall delete this file and we shall create one class. Okay. So where is it? I1. Okay, we shall delete it. Okay. So this is an interface. Okay. Now what we shall do is let us create one class class C1. Okay, let us select it first. Interface programs, class C1. Okay, so this class will be as it is. Now we have interface I1 which is having one test method, abstract non-static method, that is test method. Interface I2 as also this test method. Interface I2 also has this test method. Okay, and and here your interface I1 is having a static exam method, but interface I2 will not inherit it. Interface I2 will not inherit exam method as this exam method is static. Since your exam method is static, you can't inherit this static exam method into this interface I2. Okay. Now, in class C1, you can create one more class. Okay, later we'll create. Now, class C1, let us go for main method. Now, if you create an object for C1, C is equal to new C1 of no argument constructor. Now, now easily, easily we can we can access this elements. Okay, so see here we have an interface test method. Here also interface test method is there. So we have to overwrite in the class. Since your class C1 has to implements, class C1 implements I1 comma, you have to mention here first of all. Okay, I1 comma I2. See here, your class C1 should implement, that means it should inherit interface I1 and interface I2. Okay, now I1 comma I2 is there, but here you are getting a error because you have to implement the unimplemented method, that is your test method. You have to implement the unimplemented method, so we'll go for implementing that method. So what we are doing here, we are overriding the test abstract non-static method. Okay, test abstract non-static method, so we'll write testing here. Okay, testing here. Okay, fine. Now we can easily call c dot test method, c dot test method. Okay, and that's it. You can just create an object for the class C1 because it's inheriting interface I1 and interface I2. What if this interface is also having a same abstract non-static method? Obviously it has same non-static method only. Okay, so it has same non-static method, still you'll get the same output, that is testing. Still you'll get the same output, that is a testing. Okay, now if parent class test method, parent class test method and child class test method, see both are same. Both are same. Obviously this method is present in here also because we are inheriting it. We are inheriting that interface. Okay, if you write it also no problem, and if you don't write it also no problem. Here it will be there obviously. Okay, now in the parent class we have test method, in the child class also we have test method. So what we'll do here, instead of taking test method, we will go for result method. Result method. Now you have to override that method also. You have to override that method also. So result method, okay, we can override. We have to override because it's an unimplemented abstract non-static method. Okay, so here we will go for here result day. Okay, so what have we done here? We have created an interface I1 with the abstract method test and one static method exam. Then we have created a child interface I2 who is inheriting interface I1. So when inheriting, you can inherit only abstract non-static method. You can't inherit static method. You can't inherit static method. Okay. Excuse me. And interface I2 has its own method, that is result method. Now a class C1 is inheriting interface I1 and interface I2. Class C1 is inheriting interface I1 and interface I2. Now, okay, now what we shall do is, okay, what we shall do is, here we have seen inheritance with the help of interface, right? Inheritance with the help of interface we have seen, that is interface I1 I2 is getting inherited to class C1. Now we shall include one class here. Okay, we shall include one class here. Okay, that is class C2. Class C2. In the class C2 we'll have a non-static method, public void Okay. Heat method. I will go for read method. Okay, we shall go for reading. Shall go for reading. Okay, now. Okay, now. So now here we have one class C2. Now we have to inherit it. How we can inherit? Very easy. Public class C1 extends C2 implements I1 comma I2. Class C1 class C1 extends C2 implements I2. Always remember, one class can inherit only one class. Okay, if it is inheriting, if implement, I mean, if you are inheriting interface also, it's okay. First you have to inherit class. First you have to inherit class C2. Then you have to inherit interface. Okay. Now, how can you write? Class C1 extends C2 implements I1 comma I2. Class C1 extends C2 implements I1 comma I2. So we can even create an object for the class C2 and not needed, because we can create also and we don't have to create also, because this is a parent class. Parent class object also you can create. Okay. And using child class object only, we can even access parent class method, that is c dot c dot your read method. C dot read method. Okay. So this is how you can have your multiple inheritance, okay, with the help of interface. So you have overcome diamond problem. You have overcome diamond problem. How? Because see, in an interface you can't have a method block. In interfaces you can't have a method block. When you don't have, you have to override in a child. After overriding in a child, you should have the implementation which is in child class. You should have implementation in the child class. So whatever it is, class C1 is equal to new class C1. Obviously these methods are inherited, that is test method. After inheriting, we are overriding it. Excuse me. So after that, we are giving implementation for test method from the interface I1 and the result method from the interface I2. In case if you want to override this read method also, you can override from the parent to child. Okay, from the parent to child. If you want to override this method also, you can override. Okay, that's left to you. Now this is how we can achieve a inheritance with the help of interface. And using an interface, we are able to achieve 100% abstraction by not allowing concrete methods. And here your multiple interface problem, that is a diamond problem, has been solved. Multiple interface, that is diamond problem, has been solved. Okay. So I hope everybody has understood. Everybody got it? Okay. So final keyword you want. Okay. So let me explain you about your final keyword. Okay. So final is a keyword. Okay. Final 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 is a keyword. You can have, or you can prefix final for a variable. You can prefix final for a variable. You can prefix final for a method, and you can prefix final for a class. You can prefix final for a variable. You can prefix final for a method. You can prefix final for a class. Now a variable which is prefixed with a final, it will become a final variable. Just now we have seen no variable, static variable. Okay. The variable which is prefixed with the final keyword is called as final variable, and that final variable cannot be reinitialized. Final variable final variable cannot be reinitialized. Okay. And if a method is prefixed with a final method, if a method is a final method, that means if a method is prefixed with a final, then then that method can't be overridden. Okay, that method can't be overridden. Okay, if a final method is present in a class, okay, into the child class, it can't be overridden. Okay. And now coming to our final class. final class. The class which is final, okay, the class which is final can't be inherited. Okay, final class can't be inherited. Okay, the variable which is prefixed with the final can't be reinitialized. Okay, if you do, you'll get compile time error. And a method which is prefixed with the final cannot be overridden. You can't do. If you try to do, you'll get compile time error. And a class, if it is prefixed with the final keyword, cannot be inherited. If you try to inherit, you'll get a error, compile time error. Okay, so this is about your final keyword. Okay, and yeah, final is a keyword. Okay, and it's a modifier. Final is a keyword also. It is a keyword also because it's written in a lowercase. Okay, it's a keyword also, and it's a modifier also. It's a keyword also, as well as it's a modifier also. Okay, so this is about your final. Everybody understood about final keyword? Everybody got it about final? Okay, so can you explain again? Okay, sure. See here, in a interface, okay, see, just remember one thing. You will go for interface for two reasons. You will go for interface for two reasons. First reason is, one second guys. Excuse me guys, there was some background disturbance. Excuse me. Okay, so let us study interface. Okay, I mean we have already studied. So interface is a component in our Java. We use it to achieve 100% abstraction. To achieve 100% abstraction, we will go for interface. We will go for a interface. We will go for interface to achieve 100% abstraction. Okay. And one more thing we will go for interface is to achieve multiple multiple inheritance. To achieve multiple inheritance. To achieve multiple inheritance as well as to achieve 100% abstraction, we shall go for interface. So how we can achieve 100% abstraction is, in an interface you can't write concrete methods. You can't write concrete methods. Okay, and in an interface, one interface can inherit any number of interfaces at a time. One interface can inherit any number of interfaces at a time. Okay, at a time it can inherit. Okay, so like that you can achieve multiple inheritance, okay, in an interface, and you can avoid diamond problem. You can avoid diamond you can avoid diamond problem like this. Okay, and you can create an interface. Okay, and an interface can inherit. Okay, I mean an interface I2 inherits interface I1. While inheriting, static methods static methods are not inherited. While inheritance is going from one interface to another interface, static methods are not inherited. Okay, and and in interface you can write static methods, you can write a final static variable. Okay, and you can't write non-static method because we can't create an object for the interface. Okay, and when inheritance is going on from one interface to another interface, only abstract abstract non-static methods are inherited. Only abstract non-static methods are inherited. Okay, static methods are not inherited. Static methods are not inherited. Okay, so leaving static methods, everything will be inherited. Okay, now this is about your interface. And your interface, okay, one interface can inherit any number of interfaces at a time. Okay, one interface can inherit any number of interfaces at a time. So I interface I extends interface I extends I1 comma I2, I1 comma I2, and like this you can have a diamond problem. So who will give implementation for this interface? Only a class. For abstract class or for interface, only a class can give implementation. Only a class can give implementation. Okay, now now if you're taking a class, okay, if you're taking a class, obviously a class only should be giving a implementation to interface. If you take one class, okay, and you can inherit any number of interfaces. Suppose if you take a class C, interface I1, interface I2. Now class C implements, it inherits I1 and I2. So class C implements I1 comma I2. So class inherits any number of interfaces at a time. Class inherits any number of interfaces at a time. And how many abstract methods are present in an interface I1 and I2? They all will be implemented in a class. They all will be implemented in a class. And a class can inherit one class at a time. A class can inherit one class at a time. So you can change the class as class C extends C1 implements implements I1 comma I2, implements I1 comma I2, and this class inherits all members of class C1 and inherits except static method, everything will be inherited. Only while inheritance is going on, abstract non-static methods will be inherited or any other elements also will be inherited except your static methods. If a static method is present in I1, it will be there only. If a static method is present in I2, it will be there only. It will not be inherited. Okay. So during inheritance, static methods are not inherited. Okay. And now this C extends C1. That means it is inheriting C1 and inheriting I1 comma I2. A class can inherit any number of, one class at a time and any number of interfaces, okay, at a time. Any number of interfaces at a time. Okay. So class C extends C1, implements I1 comma I2. So like this, you can avoid a diamond problem. You can avoid a diamond problem. Okay. So this is how you can do it, and this is about your interface, and I hope everybody has understood. Everybody got the concept? Interface, everybody has understood? Guys, should you get it? Means to set a class member permanently. What? To set a class member permanently. Why we have to set a class permanently? See, no. Here, the use of final keyword. Yes. A final class you can't inherit. No, interface won't support non-static method. Interface never provides non-static method because if you write a non-static method, you have to create an object to access. Non-static members has to be accessed with the help of object reference. Okay, that is why object is not created. A static method can be written in an interface, but it cannot be inherited from one interface to another interface. Static methods cannot be inherited. Other than that, everything will be inherited. Whatever you can write in an interface, everything will be inherited except static methods. Okay, abstract non-static methods also will be inherited. Okay, only inside inheritance part cover in notes or need separate screenshot. Uh, only inside inheritance but class can do. See, for interface, only class can give implementation. For the interface abstract methods, for the abstract methods, only class can give implementation. Okay, that is why a class can inherit an interface, any number of interfaces at a time, and it can give implementation for all the methods in that interface. Okay, explanation part cover in notes. No, you don't have to take a separate screenshot. Everything is provided inside notes. You don't have to take a separate screenshot. Okay. Yes, I mean static methods. Only inside inheritance, but class can do. Uh, from a class to class, obviously, static methods are inherited. But from interface to interface, okay, static methods are not inherited. And from class to interface also, see, interface is a parent and class is a child. Whatever it is, see, if a interface is inherited to a class or interface is inherited to interface, see, both the chances are there. See here, if a interface is inherited to interface or interface is inherited to class, in both the places, static methods are not inherited. Static methods are not inherited. Only static methods. Okay. From interface to class, static methods are not inherited. Inheritance to interface also, static methods are not inherited. Okay. Okay. I hope everybody is clear with the concept. Everybody understood? Everybody got the concept? Okay, one second. Okay, you want one more program? Okay. Okay, sure. So what we'll do is okay. Same thing will be there in other programs also, same thing will be there. One program is enough. In same concept will be there in the next program also. Okay. See, in interface I1, you have an abstract non-static method, you have a static method. Into this interface I2, you can inherit only abstract non-static method. You can't inherit a static method. You can't inherit static method. Okay. And a class can be inherited to a class at a time. One class can inherit one class at a time, and it can inherit any number of interfaces at a time. Okay, so like this we can achieve your 100% abstraction and your multiple inheritance. Okay, so next program, okay, one program if you want, we shall take one new program. Okay, so shall take it as uh, okay. So we'll go for one, child two class, or parent one, parent two class. Okay. So in a parent one class, we'll have one member. In parent two class, also we'll have one method, and we'll take one child class. Okay. If you take this as an interface parent one, interface parent two, and a class child. So a class can inherit all members from parent one, all members from parent two, except static methods. Except static methods. Okay. And if this child class is not giving implementation for parent one and parent two abstract non-static methods, this child class has to become abstract. If the child class is not giving implementation for the parent abstract methods, then this child class should become a abstract, and the next level of child for this child class should give the implementation, should provide the implementation. Okay, now, so what we shall have here is parent 1. Okay, so from parent 1, parent 2, we will take one chocolates. Okay, so we shall take okay, what chocolate brands we have? Dairy milk, dairy milk chocolate method. And here we'll go for perk chocolate. Okay, now the same thing we shall implement here. Okay, the same thing we shall implement here now. Okay, we shall take one first class, we shall take, because driver class no, so we shall take it first. Let us create one child first. Okay, in a class, because we have to do in one file, means we have to first take a class. So class child. Okay, now what we shall do is we shall create two interfaces. Interface parent 1, and you have one chocolate there, public abstract void. Okay, dairy milk, dairy milk. Okay, chocolate. And here we are taking it as an abstract, because as a non-static, if you're writing, you can write only abstract non-static method. Okay, next we shall create one more interface. Interface parent, parent 2, parent 2. Now it inherits parent 1. Parent 2 inherits parent 1. Obviously this dairy milk is present in parent 2 also. Okay, so we shall take one more special method here, that is public abstract void perk method. Okay, perk method. Now we shall take class here, child class. Now this child class, this child class implements parent 1 comma parent 2. This child class implements parent 1 comma parent 2. Okay, and and here you can implement, okay, you can implement these two classes, I mean these two methods. This interface parent 1 method dairy milk and interface parent 2 method perk, you can easily implement here. How? By overriding them. So you can add unimplemented methods, you can override perk and dairy milk. Okay, so we shall go for, usually perk chocolate is, okay, so perk is crunchy. Okay, and dairy milk is chocolatey. Okay, so perk method is a crunchy, and okay, dairy milk is chocolatey. Shall tell dairy milk is chocolatey. Okay, now here you can create an object now. You can create an object now. Okay, so you can create an object, and now you can create a child object. Child c is equal to new child of no argument constructor. Now you can call c dot perk method, and you can go for c dot dairy milk method. Okay, so like this we can go for creating an object for the child, and you can call the parent class methods, parent interfaces methods. So I'll get the output parent, the perk is crunchy and the dairy milk is chocolate. Okay, so let us execute. Okay, yes, so are you getting to? Yes. Okay, now so here you have the same method here also, and in the parent 2 also it got inherited, but whatever it is, to the child class also it got inherited, and in the child class, once after giving implementation, whatever is present in the child class, that is final. Whatever is taken in a child class, that is final. Okay, and in the child, okay, you can go for object creation, and you can call the overridden methods of its own class. Overridden methods of its own class. Okay, and You can also inherit one more class to it. Okay, like this, you're avoiding a diamond problem. For one class, okay, you can, I mean, to this class, you can inherit one more class. Okay, so one class you can inherit. Okay, so you can inherit one class. Um, okay, so you can take it as um, class friend, class friend, or you can just take it as you can take it as grandparent. Okay, grandparent. Now we shall also create a child class, I mean one parent class called as grandparent. Shall create one class here now, class grandparent, or guardian, or grandparent, whatever you want you can take. So we shall go for public void. We shall go for what we can, what chocolate we can go for, dairy milk, Perk, and any chocolate brands, Kit Kat. Okay, Kit Kat methods, and here it is both sweet. Okay, we shall tell Kit Kat is sweet, sweet and crunchy. Kit Kat is sweet and crunchy. Okay, now as a child class, here we have to extends class grandparent and implements parent 1 comma parent 2. Okay, interface 1 comma, I mean interface parent 1 comma interface parent 2. Now this child is inheriting one class at a time and n number of interfaces at a time. It is inheriting one class at a time and n number of interfaces at a time. So obviously from class to class, non-static method are inherited. So you can call KitKat from here. C dot KitKat method. So you'll get KitKat is sweet and crunchy. Okay. So this is how you can go for interface with, I mean inheritance with the help of interface. Inheritance with the help of a interface. Okay. So this is it. Okay. I hope you guys understood. Everybody understood interface? Yes, guys, did you get it? Okay. Okay, that's good. Okay. So we have one more concept in an interface. Okay. That we can call it as a default method. Okay. Ma'am, only it support a non-static method, correct? No, I didn't get it. What is it? What support non-static method? Where it is used? Class and interface. One second, guys. Yes. So class and interface everywhere we can use. Okay. See, there is already a present members. If you take any software, okay, they are all the features all are presented in the form of interface. When you create an object, you are creating a class. When you are creating an object, okay, you are when you are registering to it, you are creating an object, and through that class object you can inherit all the interfaces. See, suppose you take okay, suppose you register for Paytm. What you are doing there? You are registering means what are the interfaces it has, what are the interface properties it has. You are inheriting everything. Okay, you're inheriting everything and you're using it. Okay, you're using it. Enter number. Obviously you have to register to it now first, then only we can use all the elements of it. So you can inherit all these members and you can just give an implementation. So that means you're giving your own data that you are implementing there. Okay, in every software it is there. In every software there's an interface, there's the class, there's the abstract class. It is there. Okay, it depends on the requirement. What you have to create, what you have to execute depends on the requirement. Okay. Okay, see, we have one thing here. From interface to interface, we can't inherit non-static methods, right? Can we inherit from interface to interface? Can we inherit a non-static methods? Can we inherit a non-static methods from interface to interface? Is it possible? Really? Not abstract non-static methods, normal concrete methods, normal non-static abstract methods. Can we inherit from one interface to another interface? Can we? No, we can't. Ayo. Guys, see, from one interface to one more interface. One second. See, from one interface to another interface, you cannot inherit non-static methods because you can't write non-static methods in the interface. You can't write non-static methods in an interface. And also, it can, if it is written, also you'll get a compile time error. It will not be inherited. Okay. So in an interface, you cannot write a non-static method because non-static method is a concrete method. Non-static method is a concrete method. Because of that, you'll not be able to write also, you'll not be able to inherit also. You can't do it. Non-static methods you can't inherit. You can write also, you can't inherit also. If you are able to write it, then we don't need interface. We have abstraction only. We have abstraction only. We don't need interface. So interface, we are coming to interface because two reasons: to achieve 100% abstraction by avoiding concrete non-static methods, and also providing multiple inheritance. Okay, so this is the reason you can't inherit a interface from you can't inherit a you can't inherit one interface. I mean the non-static method from one interface to another interface. You can only inherit abstract non-static method. Okay, now here, since I told you can't inherit a non-static method from one interface to interface, there comes a situation wherein you need to have one non-static method. There comes a situation, any situation you can take. Okay, you can actually do you can end up in the situation wherein from an interface I1 and in interface I2, okay, interface I2, you can you can inherit one non-static method, but that is not normal concrete method. You can inherit one non-static method that is called as default method. That is called as default method. You can inherit a default method. That is a default non-static method you can inherit. Normal non-static methods are, that is concrete methods, are not inherited from one interface to another interface. But but you can inherit default methods. Default methods means the methods which are prefixed with a default. The method which is prefixed with a default. You can go for default void m1 method in here with the blocks. You can inherit that non-static method with the blocks. Okay, here also you can have one more default void m2 method. Okay, and this is how you can have it. You can even have a same methods. Okay, you can even have a same default non-static methods. Okay, so let us see practically how it is. So now we shall create. Yes, concrete method we can't inherit obviously. Now what we shall do is, let us create one interface here. Okay, so okay, we shall create interface one. Okay, what we shall do, we'll change it to child. Okay, okay, so we shall remove this interface I1. Okay, so first we shall create okay, we shall create okay, so what we shall do is, we'll go for multiple inheritance. Okay, we shall go for multiple inheritance wherein one class will inherit two interfaces, but while inheriting it will have default methods. Okay, so we'll go for class. We can go for child, class child. Okay, child is already there, childs we can take. Okay, now we shall take one parent interface. Okay, so interface, interface. Okay, interface 1, interface name itself is interface 1, and here you can have one default method. Here you can have one default method. So default void m1 method. So we will have some implementation here. Okay, so we will tell from m1 method of, from m1 method of interface, interface 1, from m1 method of interface 1. Now we shall take one more interface, interface 2, interface 2 extends interface 1, interface 2 extends interface 1. Okay, and here we shall go for same default method, default void m1 method, and here we shall give implementation, that is from m1 method of interface 2, from m1 method of interface 2. Okay, now in the class childs, you can inherit you can inherit this implements interface 1 comma interface 2. Okay, now we shall go for creating a main method, so after creating a main method, now let us create a object for childs. C is equal to new childs of no argument constructor. Now if I call c dot m1 method, okay, now from where you think it will get inherited? If I call c dot m1 method, okay, if I call c dot m1 method, from where it will get inherited? From interface 1 or from interface 2? From interface 1 it will get inherited, or from interface 2 it will get inherited? Can you guess? C dot m1 method, from which interface it will get inherited? Interface 2. Okay, now we shall execute it and I will show you here. Okay, what is this? From m1, from interface 2. Okay, so why are getting from interface 2? Because store in that interface 2. What? Why we are getting the implementation from interface 2? Why we are getting this? You already know this. I have already taught you this. From m1 method of interface 2. Yes, it's I have written a spelling mistake. Interface 1 m1 method right now is in interface 2. Yes, because of method. Okay, method overriding. You don't have to mention at annotation, not to override annotation. Here we are overriding here. M1 method, we are changing implementation. M1 method, we are changing implementation. So we are overriding here. So when you execute M1 method, c dot M1 method, okay, you will get a method from interface 2. You will get a method from interface 2. Okay, so this is about your default methods in an interface. So from which version you got this default methods in an interface? See guys, this default method has been introduced after Java 1.8 version. Okay, Java 8 also it is there. After Java 1.8 version, okay, default methods are allowed in an interface. After Java 1.8 version, default methods are allowed in an interface, and default methods should be created with the method body. Default methods should be created with the method body. Okay, and now this behavior of these default methods in an interface. Okay, behavior of these default methods in an interface is non-static. Okay, behavior of this Default methods in an interface is non-static. And and here default methods will be inherited. Obviously, this m1 method is inherited to this m1. So obviously we are able to override. Okay, we are able to override. Why we are able to override? Because we are able to inherit this default method from interface 1 to interface 2. We are able to override, and here we are getting the c.m1 means obviously the overridden method only we will get runtime polymorphism. Runtime polymorphism. Okay, so this is about your default methods in an interface. This is about your default methods in an interface. Okay, I hope everybody understood. Everybody got the concept? Default methods in interface. Did you guys get it? Okay, that's a good thing. Okay, these are very simple actually. Okay, yes. Now, now, see guys, you know arrays is present in which package? Can you tell me arrays is present in which package? We use arrays, no. Where is it present? We are using members of arrays also, but where is your array class present? Can you guess? Yes, arrays class is present in java.util package. Okay, so now let us understand how to sort an array using a built-in methods. Okay, so now we shall understand how to how to sort an array using using built-in methods. Using built-in methods of an array. This is a great concept. I will tell you. You don't need any searching or sorting techniques. Easily, with the help of inbuilt methods, you can do wonders. Okay. In real life, these companies will use. Okay, like where more workers are there, normal companies, they will have to use this because suppose they have given a salary in a proper order, like suppose you have to get a names in an order. Okay, every names start with a, b, or whatever alphabet it is there, whatever alphabet a to z. So whatever names is there, names will get sorted easily according to alphabets. Names will get sorted according to their employee id. Everything will be sorted. Employee ids only will be sorted. Employee names will be sorted. Employee ids will be sorted if you're sorting it. And employee salaries also will be sorted in an increasing order. Okay, and one beautiful thing is you can get the elements in an increasing order also, in decreasing order also. Okay, in an increasing order, that is in a natural order. You can go for increasing order also, you can go for decreasing order. That is the beauty of this array class. Using java.util.arrays, using java.util.arrays class. Okay, you can easily go for sorting the array using built-in methods of it. You can easily sort an array using this class java.util.arrays. You can easily sort it. Okay, now let us understand this in depth. Okay, so arrays is present in your java.util package. Java.util package. Okay, and and in array we have one built-in sort method which is static. So we have one static sort method. We have one static sort method which can accept any array, and sort in ascending order. Sort in ascending order sort in ascending order. Okay, you can accept any array into the sort method. The static sort method which is present in arrays class, java.util.arrays class, that sort method which is static can accept any array, and it will sort it in a ascending order. Okay, now That itself is not enough. This sort method will just sort the arrays based on based on the logic we have written in a compare to method. Compare to of object to a method. Compare to of object method. Okay, see, sort method will accept any array. Okay, it will accept any array and it will sort in ascending order. But who will give the logic for it? Whether the sort method should sort in ascending order or descending order, who will give the logic? The logic is given by the compare to method. Okay, the sort method uses this compare to method. The sort method uses compare to method. Okay, for sorting. For sorting. Okay, the sort method, it will accept any array and it will sort it in ascending order or descending order. So that ascending order or descending order is decided by your compare to method. Okay, so sort method will sort an array in ascending or descending based on the logic which we have written, which we have, I mean, here currently it will sort in ascending order only because we are taking compare to method. So when you're going for compare to method, obviously you can sort it in one direction, that is in ascending order. Now, who is the logic giver? The logic giver is your compare to method. Compare to method gives the logic for the sort method to sort the arrays in ascending order. Okay, and see, where is this? We are talking about compare to method, but where is this method present in? This compare to method, this compare to method is present in comparable interface. It is present in comparable interface. It is present in comparable interface. So compare to method, okay, is present in a comparable interface. Okay, and for sorting any array you take, whatever array you want to take, one rule is there. Okay, all the elements in the array, okay, see, when by default your sort method is sorting by accepting array, sort method is sorting arrays based on the logic written in compare to method. But for sorting, first of all, for comparing or for sorting, all the elements all the elements in an array should belong to of comparable type, should belong to of comparable type. That means all the elements in array should be of homogeneous type. All the elements in an array should be of homogeneous type. Whatever elements you take, it should be of comparable. That means same type you need to have, and all the elements should be of homogeneous. So same elements, same type of elements you have to have, and you should be able to compare. See, if you take high and if you take 3, you can't compare. You can't compare. If you take 3 and if you take 3, you can compare. So this is what we call comparable. Okay, and so see, if you want to achieve comparable, you have to write all the elements in a homogeneous format. You have to write all the elements in homogeneous format. Okay, and if any one of the above condition is not satisfied, okay, if any one of the above condition is not satisfied, we will end up with class cast exception. Class cast exception. Okay, if the elements are of not comparable type, if elements are not of comparable type, and if elements we have not written the elements in homogeneous type. Okay, if while comparing, if the elements are not of comparable type, and while writing the elements, if the elements are not of homogeneous type, okay, if both, okay, if any one is not followed also, we will get a class cast exception. We will get a class cast exception. Okay, now first let us understand your comparable interface. Why? Because your comparative method is present in comparable interface. Comparative method is present in comparable interface. So let us understand more about this comparable interface. Okay, okay, so okay, we shall take this topic tomorrow as it is 8:46, just 14 minutes is that. Okay, so we shall have a one small round of oral mock. Okay, so part 1, who all have attended? I mean, yesterday a few of them has attended. I think one has attended. I told you to study and come back, right? So how many of you are pending still? How many of you are pending? Let me know, because I'll take it now. Be quick. Let me know. Guys, just a minute. Excuse me, guys. I just got a call. Excuse me. Okay. Today you guys didn't get any requirements, right? Any requirements you didn't get, right? Requirements you guys didn't get. Okay, guys. I think today you'll not get requirements. Maybe tomorrow you'll get requirements. Okay. Maybe today they don't have any requirements. Okay. So whose mock has is pending? Excuse me. I just got a call actually. Yes. Whose mock is pending? Can you tell me again? Whose mock is pending? Gautam. Yes, Gautam. You can unmute yourself. Be quick. Okay. Am I audible?
Okay, am I audible? Yes, ma'am.
Okay, Gautam. Now you introduce yourself nicely. Okay. 2 minutes. Fully neatly introduce. Okay. After that, I'll start with the questions.
Myself, Gautam. I am from Erode. I am I studying post graduation in Hindustan College of Arts and Science. Uh, Masters Business Administration. Um, my undergraduation is BBA in Congo Arts and Science, Erode. Bachelor of Business Administration. Uh, my hobby is learning new things, like uh, some more adventurous activities like uh,
Okay, Gautam. Just got a glitch. Yes, am I audible to you, Gautam? Gautam, am I audible to you? Guys, everyone, am I audible to you all?
I'm audible. And my voice is audible or not?
Yes, yes, yes,
Yes, yes,
Gautam, you're
yes,
audible.
Gautam, you're audible.
See, I'm getting echo. I don't know why. And that's why I'm muting you. Okay. So we'll start with the first question, and you can tell me. Yeah, we shall start with what is a data type?
Data type to store an value of an value like int, boolean, char, long, short, float, short, etc.
Tell me the
Tell
definition.
me the
No.
definition. No. Uh, to store a to store a value. Not remember, ma'am.
Have you studied?
No, ma'am.
Okay. Okay.
Okay,
I'll
okay.
take it today.
I'll take it.
I mean, tomorrow I will take. Anybody else is pending? Who is prepared? Anybody else is
Anybody
prepared?
else is prepared? Sorry, ma'am, because I had fever.
Okay. Anybody else mock is pending? Anybody else's mock is pending? Let me know. And Gautam, I think yesterday also I've taken, right? Have I taken yours yesterday? Gautam, tell me, have I taken your mock yesterday?
Yes, ma'am. Yes, ma'am.
And I told you to study and come. Starting chapter, first question I am asking you what is data type, and you're not able to tell it. You're telling all the data types, you're not telling the definition. Do whatever you want today. Tomorrow I will take your mark, okay? Whatever the ratings is there, I will give you based on your performance, okay? Okay, who all have written the test, part 1 assessment, okay? Very soon you will be having part 2 assessment also. Okay, part 2 assessment will be there, designability test will be there, and logical test will be there. Okay, anytime I can give next week, anytime I can give you part 2 MCQ test, anytime I can take oral mark for part 2, and anytime I can give you the designability test. We have solved so many designs we have done, okay, that UML designs. So make sure you study everything. Okay, so from Monday to Saturday, any day I can give you the test, designability test. Okay. Okay, guys, that's it for today. Tomorrow revision now. Let us complete this. See, interface, compare to method. I mean, comparable and comparator interfaces are pending. After that, we should go for strings. Okay. Before going for strings, after completing tomorrow's concept, okay, very soon we'll complete that half of on 1 hour. That's it. After that, we'll go for revision. Yes, we'll go for revision of part 2. Okay, guys. Today you can go early. Okay, 4 minutes early. I'm leaving you. Okay. Have a great evening, guys. Take care, guys. Bye bye.